Greetings, class. Professor Steve here, and we're going to talk about one last little phenomenon. I said little, but it's not really. It can be very big and very important phenomenon, just not quite as big as the ocean circulation patterns that we've talked about so far. And those are eddies, or something that I like to call, and some others like to call, ocean weather. And the reason I like to call them that is because they're smaller scale, essentially gyres, as we've talked about, that can happen due to long-term sort of patterns, or can even happen episodically, so unpredictably, due to actual atmospheric weather patterns. But when they set up, they actually look um, like sort of tornadoes, high in or hurricanes or storm systems, mini storm systems, but set up in the ocean water. Right? So if we recap our geostrophic flow really quick in our systems, we can have high pressure systems, we can have low pressure center systems, right? And we know that they rotate. The high pressure is always flow away from the center, always directed to the right, and so it makes it rotate clockwise in the northern hemisphere. We know the low pressure centers, the flow is always directed towards the center, but it's always directed towards the right in the northern hemisphere, and it sets up this direction this way and makes them um, rotate counterclockwise. So we have our anticyclonic versus cyclonic. We talked about how certain things can be set up due to flow near surfaces, near an interface, right? So if we have flow near a solid surface, we have our laminate flow, our persistent flow up here, and then as it begins to interact with that interface, with this interaction here, we generate turbulence. But we can also have it with two fluid mediums, right? We talked about wind going over the water. We talked about possibly two mediums going in opposite directions. And what that does is set up turbulence in one direction on one side, turbulence in one direction on the other side, and we get mixing. Right? So we talked about wind can be versus wind. Wind can be pushing on water, but we can also have water pushing on water. It could be a difference in velocity that makes these two different water masses. It could be a difference in direction, going in different directions. But it could also be a difference in viscosity, so thickness, or a difference in temperature even. Difference in density. And when we get this turbulent mixing layer and it whips up into these little spirally parcels, we call that eddy viscosity. Now, we talked about how the large-scale ocean gyres are set up, much like these large high-pressure center systems, right? And how they happen in the northern hemisphere and the southern hemisphere, and they set up the long-term surface ocean currents and patterns for surface ocean circulation. And we showed how very complex it can be, right? We have our basic gyres here, but really the velocity of the current varies depending on interaction, where in latitude it is with Coriolis, right? Stronger down here, weaker up here, so that makes very fast currents along the eastern boundary, very slow here. The wind patterns that happen in here sort of spin up other currents. The gyres rotate this way, and they spin up different currents. And what they do is bring cold from the north, warm from the south. And so that's one of the examples that I'll give you here today, or at least the most direct example I'll give you of how these ocean weather patterns can set up, or these eddies. All right, so if we have water masses of different temperature and density, so let's zoom in right over here, right? Here's our Atlantic coast. Here's the Gulf. We have this gyre, the North Atlantic gyre, set up here. We have the equatorial currents coming through here, and we have currents coming out of the Gulf, and that forms the Gulf Stream, right? It drags this warm water in the Gulf stream out up along the Atlantic seaboard and out across the Atlantic. But we also have cold currents coming down from the north along our Atlantic seaboard, and these two currents pass each other. And this is sort of a representation of that, a schematic of that. So we have warm, a different temperature, a warm temperature, different density um, Gulf Stream going this way. We have northern colder currents coming this way. And we get this interface. We get this eddy viscosity that goes on here, this turbulent mixing. Sorry, let me take a step back. So what happens is, as this mixes, we get cold water mixing into the warm layer. We get warm layers mixing into the cold layers. And so they spin up into these systems, and what they do is set up these pressure centers. And this is a neat little model that sort of shows that happening. Here we have our Gulf system coming through. Right? As it goes, we get turbulent mixing spots. Right? And you can see that we can have entrainment here. So this warm Gulf wrapping around and pinching off in this turbulent spot some of the cold. So it's surrounded by warm water, but with a cold center. Sets it off spinning in a counterclockwise low pressure center, right? But we can also have warm water getting pinched off here and trapped by some cooler water and spinning off in the other direction clockwise in what is a high pressure center. Okay, and these are eddies. These can be many, many kilometers wide, and they're like basically ocean weather systems that spin off. So there is a pretty decent significance to these because they mix up and churn the waters. There's ecological significance for biology that we won't really get into here yet, but we will soon. But let's take our cross section and then dissect the effect on our pressure systems, right? If we have those high pressure centers that pinch off with warm water trapped in the middle, they're moving clockwise, but they trap that warm water in the center, and so we call them warm core rings. If we have our low pressure centers that pinch off, trapping the cool water in the center, we call them cold core rings. And there's another reason we call them cold core rings, and once they set up, they're sort of self-sustaining. And again, we'll get to that in another lesson, but I just wanted you to be aware of these as part of the ocean's circulatory patterns because they're happening right now, and they happen. Sometimes these things can be spun off episodically, like I said, from atmospheric weather events, but they can also be set up by these long-term interactions or interposing surface currents, like the Gulf Stream going this way and the northern currents coming down this way. And here's a real satellite image of the sea surface temperatures, and you can see here are some eddies that have spun off. This one's kind of petering out. Here's a new one forming, coming in, going counterclockwise with cooler water trapped from up here and entrained by this warm Gulf Stream water. And here you can see you have eddies that are spinning off, and we have warmer water going and a system rotating clockwise and surrounded by colder water. So we have our warm core rings and our cold core rings.